Everyone, welcome to numerical problem of kinematics. There are few numerical problems which is very important for exam point of view. And the first numerical problem is find the angle of projection to get the maximum horizontal range, or this question is asked in this way: at what angle the stone is projected for the maximum horizontal range. First of all, we know horizontal range is given by r u square sine 2 theta upon g. For maximum horizontal range, sine theta equal sine 2 theta equal to 1. So sine 2 theta equal to, we know the value of sine 90 equal to 1. So in the place of 1 we can write sine 90 degree. Therefore 2 theta equal to 90, then theta equal to 90 by 2, so theta equal to 45 degree. So for maximum horizontal range, theta must be 45 degree. And next one is find the angle of projection at which the horizontal range and maximum height of projection are equal. Let theta be the angle of projection. Then in the question given, horizontal range equal to maximum height. So the formula of horizontal range is u square sine 2 theta upon g, and maximum height is u square sine square theta by 2g. So from this equation, u square and u square cancel, g and g cancel. So sine 2 theta equal to sine square theta upon g. So the formula of sine 2 theta is 2 sine theta into cos theta equal to sine square theta upon 2. So this sine theta and this sine theta cancel, and here is a square, so 1 sine theta is rest. So 2 cos theta equal to sine theta upon 2. After cross multiplying, we can get tan theta equal to 4 and theta equal to tan inverse 4. So theta equal to 76 degree to the horizontal. We have to find the angle of projection. So angle of projection is 76 degree. And next problem is a little red wagon with mass 7 kg moves in a straight line on the frictionless horizontal surface. It has an initial speed of 4 meter per second and is pushed 3 meter in the direction of initial velocity by a force of 10 Newton. Calculate the wagon final speed and the acceleration produced by the force. And first of all, the given data is mass of object m equal to 7 kg, initial speed of object u equal to 4 meter per second, distance travel yes 3 meter, applied force F is 10 Newton. This is the given data, and we have to find final speed b equal to what? First of all, we know acceleration equal to force by mass, so 10 upon 7 is 1.428 meter per second square. And again we have the equation v square equal to u square plus 2as, and this is final velocity, this is initial velocity, and we have in the question we have to find the final velocity. So initial velocity is 4 plus 2, value of a we have already find above, into s is 3, so 9.46 meter per second. Similarly, next question is what would be the effect on the range of doubling the initial velocity? When the object is thrown with a velocity u at an angle theta with horizontal, the horizontal range is given by r equal to u square sine 2 theta or sine 2 alpha upon g. This is equation first. If the velocity is double, that is u equal to u dash is to u naught. This is initial, so u naught. The horizontal range will be r dash will be u dash square plus 2 sine 2 theta upon g. So 2 u the value of u dash is 2 u naught, so 2 u naught square into sine 2 theta upon g, that is 4 u naught square sine 2 theta upon g is u naught square sine 2 theta upon g. This is not alpha, this is theta. This value is r, so 4r, therefore r dash equal to 4r. And the next problem is when a ball is dropped from a height of 20 centimeter, 20 meter, this is not centimeter, this is meter. It rebounds with a velocity which is 3 by 4 of the velocity with which is hit the ground. And determine the time interval between the first and second bounce. We have to determine the time interval between first and second bounce. Initial case s equal to 20 meter. This is the height from B to A, and escalation due to gravity g equal to 10 meter per second. 10 meter per second square. This is not only 10 meter per second. And initial velocity u equal to 0, final velocity we have to find. We know u square equal to b square equal to u square plus 2 gs. So b equal to root under u square plus 2 gs. Put the value of u, g and s, we can get final velocity is 20 meter per second. And time taken equal to b minus u upon g, that is 20 minus 10, 0 upon 10 is 2 seconds. Again, final case, initial velocity is 3 by 4 of final velocity. This condition is mentioned in the question. So 3 by 4 into 20, that is 15 meter per second, and escalation a equal to minus 10 meter per second square, that is final velocity b dash equal to 0. And now the time taken to reach the maximum height t1 equal to b dash minus u upon g, that is 0 minus 15 upon 10. So this is 15 uh, 15 by 10 is 1.5 second. Total time taken to reach the ground t2 equal to 2 into 1.5, it is rebounds, so 2 multiplied by 2, that is 3 second. And time interval between first and second bounce is also 3 second. This is the time interval between first and second bounce. And similarly, next problem is an object of mass 10 gram is thrown vertically upward with a velocity 100 meter per second having angle 60 degree to the horizontal. Calculate the time of flight and maximum height attained. In this case, we have to know the formula for time of flight and maximum height. So in the question given, mass of object 10 gram, velocity 100 meter per second, angle theta 60 degree, and time of flight uh, and maximum height attained. We have to find this both. Now time of flight t equal to 2u sin theta upon g. So u is 100 and theta is 60 degree, value of g is 10. So time of flight is 17.32 second. And the next one is maximum height, that is u square sin square theta upon 2g. So 100 square into sin square 60 upon 2 into 10, that is 375 meter. And the next problem is a projectile fired from a ground level with a velocity 500 meter per second at a 30 degree to the horizontal. Find the horizontal range, the greatest vertical height to which it rise, and the time to reach the greatest height. Velocity 500 meter per second, angle of projection with horizontal theta 30 degree, and this is the figure of projectile fired from the ground. For horizontal range, we have r equal to b square sin 2 theta upon g. So put the value of v, theta and g, we can get the horizontal range is 21650.64 meter. And for maximum vertical height, we know a formula for vertical height equal to h equal to b square sin square theta upon 2g. So 500 square into sin square 30 upon 2 into 10, that is after simplifying this we can get 3125 meter. And now time taken to reach the maximum vertical height t equal to u sin theta upon g. Value of u is 500 into sin 30 upon 10, that is 25 second. And next problem is an object is dropped from the top of tower of height 156.8 meter, and the same time another object is thrown vertically upward with a velocity of 78.1 meter per second from the foot of the tower. When and where the object meet. This is the tower, and let's see. Height equal to 156.8 meter. Initial velocity u equal to 78.1 meter per second. Let A be the position. This is the top. So position of top of the tower, and B be the position of the ground. And C, assume they meet at point C. A and B meet at point C. From the dropped object, distance move equal to, we know distance formula of distance, S equal to ut plus half gt square, and u is initial velocity is 0, so u into 0 plus half gt square. Therefore this S is x, this is x, so x minus 1 by 2 gt square, this is equation 1. Again, for projected object, S equal to ut minus 1 by 2 gt square. Value of S is s minus x. This is s minus, this total is s, and this is s minus x. So s minus x 78.1 into t minus 1 by 2 gt square. In the place of x, we can write this half gt square. So half gt square and half gt square cancel. Therefore, S equal to 156.8 equal to 78.1 t, that is t equal to 2 second, and substituting t equal to 2 second in equation 1, that is x equal to 1 by 2 into 10 into 2 square, that is 20 meter. Hence they meet below 20 meter from the top of the tower in 2 seconds. Next problem is, a batter hits a baseball so that it leaves the bat with an initial speed of 37 meter per second at an angle of 53 degree. Find the position of the ball and magnitude and direction of its velocity after 2 seconds. Treat the baseball as a projectile. And the initial velocity equal to 37 meter per second given angle of projection theta. This is 53 degree, not 35, this is 53 degree. And time taken t equal to 2 seconds. We have to find velocity and position x. Now after 2 seconds, v equal to u vx. This is horizontal component is cos theta and vertical is sin theta. So vx equal to u cos theta 37 into cos 53, that is 22.27 meter per second, and vy equal to uy minus gt. So the value of uy is u sin theta minus gt, that 37 into sin 53 minus 20, 9.55 meter per second. And for position, x equal to vx into t, and the value of vx is 22.27 into 2, 44.54 meter, and y equal to uy t minus half gt square. So in place of uy, we can write u sin theta into t minus half gt square. After calculating this, we can get y equal to 39.1 meter. So the position of projectile x and y 44.54 and 39.1, and the velocity equal to root under vx square plus vy square. Putting the value of vx and vy, we can get the magnitude of velocity is 24.23 meter per second, and tan theta equal to vy upon vx. So theta equal to tan inverse vy upon vx, tan inverse 9.55 upon 22.27, that is 23.21 degree. So the magnitude is 24.23 and direction is 23 point, and the direction is 23.214. And this is the last problem of kinematics. A stone on the edge of vertical cliff is kicked so that its initial velocity is 9 meter per second horizontally. If the cliff is 200 meter high, calculate time taken by the stone to reach the ground. How far from the cliff the stone will hit the ground? Initial velocity 90 meter per second, cliff height 200, time to reach the ground we have to find, and horizontal range we have also find. We know S equal to uy plus half gt square, that is ut plus half at square. Therefore in place of yes, we have already given 200. Initial velocity is uy is 0 into t upon half. Value of z is 10 and we have to find t. So after simplifying this, we can get the value of t equal to 6.32 second. And horizontal range or horizontal distance covered are equal to ux into t. So 9 into 6.32. This is not 90, this is 9. 9 into 6.32, that is 56.32 meter.